Header file for my GPIO Deacon class. It keeps the interface separate from the implementation, so the main Arduino sketch can call clear functions instead of directly touching registers. The constant GPIO group size is set to 6 because this task requires 6 LEDs. The two important new methods are GPIO setup port X and GPIO display port X. GPIO setup port X receives a port number, a 6-element pin array, and a 6-element mode array. GPIO display port X receives the same port and pin array, plus a 6-element pattern showing which LEDs should be on or off. The private helper functions keep port lookup, pins validation, and binary value validation inside the class. This implementation file is where the CMSIS register success happens. Get port group converts the character A or B into the correct SIT329 port group pointer. In GPIO setup port X, the code checks that the arrays are valid, checks that each pin number is below 32, and checks that every mode value is either 0 or 1. For output pins, it builds an output mask and writes to direction sets. For input pins, it builds an input mask, writes to direction clear, and enables the input buffer using the input enable bit. GPIO display port X works in a similar way, but it builds a high mask and a low mask from the display pattern. It writes outsets for the LEDs that should turn on and out clear for the LEDs that should turn off. This specifies the task requirements because the GPIO outputs are controlled through the GPIO Deacon class and CMSIS registers, not Arduino pin functions. This is the main Arduino sketch. I selected pins D4 to D9 because they all maps to port A pins on the SIT329 used by the Arduino Nano 33 IoT. In the code, LED port is A and LED pin stores the 6 physical port pin number 7, 5, 4, 6, 18, and 20. LED mode is all ones because all 6 LEDs are outputs. In setup, the program calls GPIO setup port X to configure all 6 pins, then call GPIO display port X with all off to start from a known off state. In loop, current mode is pulled. Mode 01 twinkle stars, mode 1 runs starfall, and mode 2 runs star race. After each mode finishes, current mode changes to the next mode, so the demo automatically shows all 3 required lightning behaviors. Display timing is handled by delay, which is the only Arduino API function used for lighting timing. In Twinkle Stars, blink all is called with a 100 millisecond half period. One full on-off cycle is therefore 200 milliseconds, which is 5 Hz. In Starfall, the half period is 1000 milliseconds, so one full on-off cycle is 2000 milliseconds, which is 0.5 Hz. Star Race. Use the half period milliseconds array to move through 0.5, 1, 2, 3, 4, and 5 Hz, then back down to 0.5 Hz. Each frequency step runs for 5 blinks. For the random pattern, the program uses a small deterministic pseudo-random generator and changes a 0 pattern to 0 times 3f, so the random display does not show a full or off blink. For the hardware demonstration, 6 LEDs connected to pins D4 to D9. After upload, the first visible behavior is twinkle star, where all 6 LEDs blink quickly together at 5 Hz. The second behavior is star fall, where all 6 LEDs blink slowly together at 0.5 Hz. The third behavior is star race, where the 6 LEDs show changing random patterns and the blink speed increases up to 5 Hz and then slows back down. This demonstrates that the GPIO Deacon class can control a group of 6 GPIO pins and display the required lighting modes.